Good morning all. Today we are going to discuss module 2 on engineering mechanics. So in module 2, first part deals with friction. So here we are going to discuss what is friction, what are the terms related with friction. Then we are studying the laws of friction that is related with both the static and dynamic friction. Then we will be analyzing bodies subjected to friction, that is analysis of single bodies. Also we are dealing with analysis of connected bodies. Then we will see the application of friction on wedges and ladder. Second part we will be dealing in another video. So first we will see what is friction. When a body moves or tends to move over another body, a force opposing the motion develops at the contact surface. This force, which opposes the movement or the tendency of the movement, is known as frictional force or simply friction. So friction is nothing but the resistive force offered by a body when another body slides over it. So here you can see a pushing force is applied to the right. So due to that external force, the body has a tendency to move to the right. So friction will be developed opposite to the direction of motion. This is very important. You have to remember that friction always develops opposite to the direction of motion. So now in the figure you can see the friction is developed at the contact surface. That's the second point you have to remember. Friction always acts at the point of contact between the two surfaces. The friction is mainly due to the resistance of motion offered by minutely projected particle at the contact surface. So the major cause of friction is interlocking of these minute projections on the surface. And the amount of friction depends on the material from which the two bodies are made. The rougher the surface, more friction will be produced. So if a surface is perfectly smooth, frictional force will be zero. So more the rougher surface, more friction will be produced. And the major reason for the friction is this interlocking of the minute projections. Next we will see what is limiting friction. The frictional force has a remarkable property of adjusting itself in magnitude. So when a force tending the motion increases, then the frictional force increases. But there is a limit beyond which the magnitude of frictional force cannot be increased. So the maximum value of frictional force is known as the limiting friction, which is the frictional force when the body is in impending motion. So limiting friction is the maximum frictional force that is developed at the contact surface when the body is in the verge of motion. Actually the body is not moving, body has a tendency to move. So when the applied force is greater than the limiting friction, body moves in the direction of applied force. And when the applied force is less than limiting friction, the body remains at rest. So that part you have to remember. So next is the type of friction. So first one is the static friction. So frictional force experienced when the body is at rest, that is known as the static friction. Second one is dynamic friction. Friction experienced by a body when it is in motion, that is known as dynamic friction. The dynamic friction is found to be less than limiting friction, and this dynamic friction is again classified into sliding friction and rolling friction. Sliding friction is the friction experienced by a body when it slides over another body, and the rolling friction is experienced when a body rolls over another body. Next is the terms used in friction. First one is the coefficient of friction. The magnitude of limiting friction bear a constant ratio with the normal reaction. So this ratio is known as coefficient of friction. So this coefficient of friction is given the notation mu. So in your question paper, this is a sure question, because in most of the question paper you can see this definition: define coefficient of friction, define angle of friction. These are the terms used in friction. So you have to write the definition and you have to include the equation also. So the notation of coefficient of friction is mu. Mu is equal to F by Rn, where Rn is the normal reaction. So here instead of Rn you can give the notation as capital N. So in this equation, F is the frictional force and capital N is the normal reaction. So next is the laws of friction. First we will see the laws of static friction. First one is frictional force always act in a direction opposite to the direction of the force. Second point is magnitude of frictional force is equal to the external force. And the third one is the definition of coefficient of friction, the ratio of the limiting frictional force to the normal reaction as a constant. And fourth point is friction depends upon the nature of the surface and it does not depend on the area of contact. So fourth point is friction does not depend upon the area of contact. It depends upon the roughness of the surface. So next is the laws of dynamic friction. Frictional force always act in a direction opposite to the direction of motion. Second point is again the definition of coefficient of friction, the ratio of limiting friction and the normal reaction as a constant. And the third point is different from the previous. So third point is for moderate speed, the frictional force remain constant, but it decreased slightly with increase in the speed. So this is also a sure question. You have to mention the laws of friction, that you have to include both the laws of static friction as well as the dynamic friction. So it's a 3-mark question. So next definition is also very important, that is the angle of friction. So in the figure you can see a body. An external force P is applied to the right side So body has a tendency to move to the right. Then you have to mark the direction of friction. So it is towards the left. So when you draw the free body diagram, you have to include the external force, friction, then weight is acting downward. So there will be normal reaction to oppose the weight. So it will be acting upward. So these are the four forces acting. So now if you calculate the resultant of the frictional force and the normal reaction capital R. So that part you have studied in your module 1. So if you are given two forces, you can calculate the resultant. So here S represent the resultant. So next we will see what is angle of friction. So in the figure you can see a body which is subjected to an external force P. So when it is moving towards the right, friction will be acting towards the left. So when you draw the free body diagram of this body, weight is acting vertically downward and there will be normal reaction exerted by the horizontal surface. So if you find the resultant of the normal reaction and the frictional force, you will get the value for S, that is the resultant. So now angle of friction is defined using this resultant S. Angle of friction, it is the angle between the normal reaction at the contact surface and the resultant of the normal reaction and the limiting friction. So from the figure you can see normal reaction is capital R. S is the resultant. Angle between these two forces is represented as phi. Tan phi is equal to F by R. That is opposite side by adjacent side. So from this you will get the value for tan phi as equal to mu. In some problems you will be provided with the angle of friction. So if you are given the angle of friction, you have to calculate the value for mu. Mu is equal to tan phi. So this is also a very important definition. So now we will see simple problems. So first problem is a body of weight 90 Newton is placed on a rough horizontal plane. So rough horizontal plane means friction is acting. To determine the coefficient of friction, if the horizontal force is 63 Newton, just cause the body to slide over the horizontal plane. So here you can see the force acting on the body. This is the free body diagram. So horizontal force is acting towards the right, frictional force towards the left. Then you have to include the weight. Weight is acting downward. So there will be normal reaction exerted by the horizontal surface that is acting upward. So these are the four forces acting. So now we have to apply the conditions of equilibrium for a concurrent system. So here you can see three forces are meeting at a common point. So we naturally assume the fourth force towards the center. So it is not acting at the center because it is acting at the surface of contact. But for the analysis purpose we are assuming like that. So all the forces form a concurrent system. So first equation of equilibrium we are using is sigma f y is equal to 0. So Rn minus W is equal to 0. From that you will get a value for Rn. Second equation you have to use is sigma fx is equal to 0. So 63 minus mu Rn is equal to 0. So mu is equal to 63 by Rn, that is equal to 0.7. Second problem, a body of weight 200 Newton is placed on a rough horizontal plane. If mu between the body and the horizontal plane is 0.3, determine the horizontal force P. So in the first problem, you are provided with P. You have to calculate mu. In the second problem, mu is given and you are supposed to calculate the value for P. So first step is you have to draw the free body diagram. So in the free body diagram, you have to mark the direction of external force. So external force is acting towards the right. We have to assume that if the figure is not given in the question. So external force is acting to the right, friction towards the left. Then weight is acting vertically downward and reaction, that is the normal reaction exerted by the horizontal surface, that is acting upward. So here also you have to follow the first equation as sigma Fy is equal to 0. So sigma Fy is equal to 0 is given. Another notation, sigma V is equal to 0. Or you can write the same equation as sigma capital B is equal to 0 or sigma Y is equal to 0. So whatever be the notation, the first equation we are using is sigma Y is equal to 0. So all the vertical forces are equated to 0. So capital R minus 200 is equal to 0. So capital R is equal to 200. Second equation you have to use is sigma Fx is equal to 0. That is all the horizontal forces are equated to 0. Here the notation they have assumed is sigma H is equal to 0. So minus F plus P is equal to 0. From this you can calculate the value for P. P is equal to 60 Newton. And the third question, you are given a block 200 Newton placed on a rough horizontal floor. If mu is equal to 0.25, find the pull required to move the block if P is inclined upward at 30 degrees. So here also the figure is not given in the question. You have to assume it as a pull. Pull is acting at an inclination 30 degree to the horizontal. So here force P is making an angle 30 degree with the horizontal. The horizontal component is responsible for the motion along the horizontal plane. And here the horizontal component is P cos 30 because P is making 30 degree with the horizontal axis or the x-axis. So x component is P cos 30. So that is responsible for the motion. So body is moving towards the right, friction is towards the left. Then weight is acting along the y-axis, normal reaction is acting upward. So first equation, here you have to follow is sigma Fy is equal to 0. So here the component of P along the y direction is P sin 30. So that force you have to consider while considering the equation sigma Fy is equal to 0. So first equation is Rn plus P sin 30. P sin 30 is the vertical component of P. Then minus 200 is equal to 0. So Rn is equal to 200 minus P sin 30. So after getting the value for Rn, you have to use the second equation sigma Fx is equal to 0. So here you have to write P cos 30 minus mu Rn, that is equal to 0. So by solving the second equation, you will get P is equal to 50.45. So now the last question is a homework. So the force required to pull a body of 15 Newton on a rough horizontal plane is 15 Newton. Determine mu if the force is applied at an angle 15 degree with the horizontal. So here the weight of the body is given, the horizontal force is given as 15 Newton. It is making 15 degree with the horizontal. You have to calculate the value for mu. So in the previous problem, you have to calculate the force. Mu is given in the question. So in the last question, you are provided with force 15 Newton, you have to calculate mu. So you have to write all these topics in an A4 sheet and you have to bring on July. So we will continue with the next topic in next video. So till then, thank you.